Welcome back to the Children's Science Center Lab DIY series. My name is Lahiri.
My name's Ashlyn.
And we are going to do some inflatable colors today. So Ashlyn, what's this activity about?
Well, first off, we said colors. So we're going to try and see how many colors of the rainbow we can see using our pH indicator. So you might not have a universal indicator at home, but things like grape juice, cabbage juice, and berry juice will also change colors in the same way this does.
Okay.
So you can use that too. So our pH indicator is going to indicate or tell us if something's an acid, a base, or neutral. Do you know what an acid and a base are?
Kind of, but you want to tell me a little bit more?
Yeah, so sometimes when we think of acid, we think, it's going to burn my skin off, it's an acid. But we don't really mean that, do we?
No.
Have you had any orange juice this morning?
I did.
What about any apples?
No, because I had my orange juice. I didn't need more apples.
Do you have coffee?
I did.
So those are all acids. Let me show you here. Ding, 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 ding.
Here, let me hold that for you.
Okay. Great. So in the top, we have our acids. So those have more hydrogen atoms. You have soda. Battery acid is the most acidic thing. That one's actually a little dangerous. But the rest of them are stomach acids, help us out. Citrus, like lemons or limes, we can all eat those. Coffee, slightly less acidic. Then neutral in the middle are things like milk or water, actually. Eggs, pretty neutral. I like eggs for breakfast. Then as you get to the other side, you get things that are more basic. So those tend to be cleaning supplies. So bleach is one of the most basic things. Borax, which we use for slime and laundry detergent, pretty basic. Baking soda, pretty basic. Soap, things like that. So let's see, I'm gonna put this in here and let's see what color it is at first. Will you tell me what color this is, Lahiri?
That looks like green to me.
It's pretty green, that's where it starts off. Now let's pour in our water and see what our water falls on the pH scale.
Ooh.
What do you think?
I think it falls on right about here.
Oh, neutral, yes, our water's neutral, that's a good thing. All right, so now let's get in our acids and our bases. What acids and bases did you bring for me?
So I have some baking soda already pre-pepped in this little container. And I think you can find baking soda around your home too. If I can open this container. There we go.
Which we use for baking.
Yes.
And
baking.
for soda.
Yeah.
Not for soda, just for baking.
Yeah. Also keeps your fridge smelling nice and clean. And I also have some citric acid, which is the results of all the fruits, right? Like all the citrus. So those are the two that I have for you, but they're in separate containers right now because we don't want them to mix.
Well, we're actually going to mix them together.
Okay.
And see what happens. So can you pour your baking soda right in the middle of your square for me?
All right. I just have a little wax sheet of paper, not wax, tissue paper, right in front of me that we're going to pour this baking soda into.
And then pour the citric acid right in the same center of the square.
All right.
We're going to get it mixed in there. And you might not have citric acid at home, but you can use lemon juice, vinegar, rubbing alcohol, different types of acids.
Okay.
All right, so we're going to fold it up.
How?
Take the two opposite corners and make them meet in the middle.
Okay.
And then the other two opposite corners, make those meet in the middle. And then we're going to twist it together like a little dumpling or a little package. But we're not going to eat this.
We never eat our science.
Unless we're baking.
That's true.
I like to eat my cookies.
All right. Is that good?
All right, yeah. So I will hold the package. I'm going to have you drop it in. Bloop. And then we're going to pour it in our water.
Okay.
So the water is going to speed up our reaction, and I'm going to close this as quickly as possible after we turn our water. Oh, there we go, there we go. What color is it turning now?
It's red. Orange? Yeah, I see orange and I see red. There's still a little bit of green in there too. But wait, something's happening to the bag too. I can't see it right now. What's happening to the bag?
We're producing a gas right now. So everyone take a deep breath in, deep breath out. We're breathing out carbon dioxide. That's the same gas getting produced here. Do you see it trapped in the little bubbles?
Yeah, I see a lot of bubbles. I know you can't hear it, but I can also hear the bubbles in this.
It's kind of like when you open a can of soda and it fizzes.
Yeah.
The carbon dioxide in there does the same thing, and it's actually starting to inflate our bag. So normally we can't see gases with our eyes, right? The air around us is invisible. So that's why we're using the bag to capture the gas so we can see how much gets produced. And then it turned red. Why do you think it turned red?
Because the citric acid inside, it got released into the water. And
Exactly.
So, but there's also baking soda, which is base. It was a base, right? So it should be blue. So why is it not a mixture of these colors anymore?
That's a good question. Even though we use the same amount of the base and the acid, acids tend to be more powerful than bases. So they overpowered, and this is more acidic than it is basic right now. Over time, it might change back. If we open it up, it could change back again. But if we leave it here like this, it'll stay pretty red. Another reason is when the water comes into contact with the carbon dioxide we're producing, it makes carbonic acid, which, as you can guess, carbonic acid is an acid. So any base and acid reaction will make this happen.
Okay, all right. Are you afraid that it's going to pop?
A little bit.
Yeah.
Yeah, but that's kind of the fun, right?
Yeah.
You can feel it's really, really
Oh, yeah.
tight there. What do you think would happen if we opened it up?
I think it would release all the gas, right? So this will deflate. I don't know if it'll pop or make a noise, but yeah.
You want to try it out?
Okay.
Oh, nothing happened.
That was really neat. That was a neat acid-base reaction. Thank you for sharing that with us, Ashlyn.
Of course. Hope you guys join us next time.